All right, guys, we're going to look at exploring equations. Now, equations you guys did back when you were in Algebra 1. Most of you guys are familiar with solving equations. This approach we're going to look at today is a little bit different from what you guys maybe have seen. We're going to use the calculators to help us out solve equations. So, up at the top, basically they give us a rundown how this is going to work. So they give you an example of an equation. Up here at the top, they give you a sample. It says 2x minus 1 is equal to x plus 4. Now, we could work that out algebraically, or if we're too lazy and we want to take shortcuts, we can also use the calculator. And basically what it's saying is, we can take the left side of the equation and put it into y1. We can take the right side of the equation, put it into y2, graph those two lines, and ask the calculator to find an intersection for us. And whatever that intersection is, like in this case, that intersection is right here at 5. That 5 represents the actual solution. All right, so I'm going to show you how to do that with your calculator here in a second. So again, all it is left side goes into y1, right side goes into y2. You find the intersection, and voila, you got your answer. All right, so let's take a look at some examples and see how this is going to work. First example, number 1, we're working with the equation negative 2 times 17 plus 5x is equal to negative 2x minus 2. Now again, we could do this by hand, or we can take the lazy way out of it and use the calculator, which is what we're going to do right now. So here's the first thing I need you to do. The left side of the equation, we're going to put that in y1. So on your paper, I want you to put down where it says y1, negative 2 times 17 plus 5x. That's going to go in y1 here in a second. In y2, we're going to put the right side of the equation. We're going to type in negative 2x minus 2. All right, so now that we know what we're going to type in, let's go ahead and do that. Let's actually type it in. So let me grab my calculator. Here's my calculator. Again, we're going to go to y1, y equals, and in y1, I'm going to type in negative 2, parentheses, 17 plus 5x, close the parentheses. Now we're going to go to y2, and we're going to type in negative 2x minus 2. We all got it? Now we're going to go ahead and hit graph. And this is the graph we get, right? That's everything you got? Let's go ahead and sketch that over here where it says sketch the graph. So just kind of look at it there. It doesn't have to be perfect. We've got something that looks kind of like this right here. Doesn't have to be perfect. We're going to find the intersection here in a second. All right, so this is a rough sketch of what the graph looks like on our calculator. Now we're going to tell the calculator to find where these two lines are crossing. Where do they intersect? Right there. So how do we do that? Anybody know how to find the intersection? Second. All right, second calc or second trace. Go to second trace. And you'll notice number 5 there says intersection. That's the one we're going to use. Number 5, intersection. Now keep in mind you are going to have to hit enter 3 times before it actually finds that intersection for you. So hit enter 1, 2, and 3 times. And notice you get 2 numbers down at the bottom. Those 2 numbers are important. As a matter of fact, I want you to write those 2 numbers down for me over here underneath the sketch of your graph. So the 2 numbers we got were negative 4 and 6. So down here we're going to write those 2 numbers down. Negative 4 and 6. Now, how does that help? Well, the answer to this equation is sitting right in front of you. It is right here. It's negative 4. So out here where it says solution, we're going to write down that solution, which is x equals negative 4. Now, notice over here it says show the table. Show the table. We can also see that same solution in our table. Everybody go to second graph. Go to second graph. And in your table, I want you to go and find negative 4. Find negative 4. There it is. And notice the two numbers you see right next to the -4. I want you to write it down over here in your table. -4, right next to the -4, you see a 6 and another 6. That's important. Let's look at some of the other numbers. Right next to -5, you see a 16 and an 8. 16 and 8. Right next to -3, you see a -4 and a positive. -4 and a positive. So if for some reason we can't see it on our graph, you can also go to your table and look for it. And what exactly you're looking for in the table? You're looking for where those two y values are exactly the same. Like in this case right here, 6 and 6 are the same y values, which means the intersection occurs at -4, +6. And we only, of course, need the x value. X value is what we're looking for. Okay. Anybody ever used this before? Y'all seen this back in Algebra 1? Did I show you this little trick already? All right, so some of you are familiar with it. Let's try another one. Let's go to number 2. Number 2. We're going to do it the same way. The left side of the equation, this right here, that's what we're going to type into y1. This right here, -3x + 1, that's what we're going to type into y2. So the left side of the equation goes into y1. Right side of the equation goes into y2. So y'all go ahead and do that for me. Go ahead and put it in your calculator. Sketch a graph of it. And then find the intersection. Now you probably noticed when you sketch the graph, where those two lines intersect, where they cross that, you can't actually see it on your graph. You can't actually see it on the calculator. Matter of fact, you get something that looks kind of like this. One line does this, and the other line does this. You don't actually see where they intersect. However, when you tell the calculator to find the intersection, it doesn't need to see it. It'll find it anyway. All right, so did anybody find it? What were the two numbers you see down there at the bottom? What was it? 4 and -11. Let's put those two numbers right down here at the bottom. 4 and -11. Again, the answer, the solution to that equation is right in front of us. It's this number right here, x = 4. So put that down as your solution. But again, if for some reason we can't tell what it is in our graph, we can also find that in the table. If you go to your table and look right next to the -4, what you're going to notice is two numbers. And those two numbers happen to be both -11. If you look right next to the 3, the two numbers you see are -15 and -8. If you look right next to the 5, you should see a -7 and a -14. So anytime we're looking in the table, all we're looking for is where is it that the two y values are exactly the same number. If we can find that, you can find your solution. All right, let's go to number 3, one more. Now this one, I'm going to show you a little trick on this one, but first of all, the left side goes into y1, so we're working with 3/14, x - 4. That's what we're going to put in y1. In y2, we're going to put in 3/7, x + 1. Now notice we got some fractions here, guys. I want to remind you that we had an update on our calculator, and our calculator can do some fancier things now. And I want to show you that real quick here. Let's go to our calculator, and let's go to y equals. Clear everything that you have in there already. Clear it all out. Now remember, in y1, we're trying to type in 3/14 times x - 4. And before we had our updates, fractions, we always had to put them in parentheses. We don't have to do that anymore, because we got a new feature here. So let me show you that. I want you to hit the green button, the alpha button, and then I want you to hit the y equals. The green button, and then y equals. And you're going to notice this little screen that pops up now. The very first one has n, and then a little slash, and then d. N divided by D. N divided by D. What does N stand for? Anybody want to take a guess what N is going to stand for? Numerator. D stands for denominator. We have a numerator and we have a denominator. That's the one we're going to use. So select number 1. And you'll notice what pops up here now is this little thing that looks like a fraction. Now all we have to do is type in the numerator, which is going to be a 3 for us. Then hit your little arrow key to go down and type in your 14, your denominator. Now if I keep typing, it's going to keep thinking that it's part of my denominator. So I want to hit the little right arrow key so that I don't type underneath the fraction anymore. So now we got 3 over 14. Let me get my parenthesis. X minus 4. Close your parentheses. So now it looks exactly like we see it on our paper. We don't have to use the parentheses anymore. We'll go down and do the same thing in y2. We want 3 over 7. So let's do that again. Alpha, y equals. We're using the first one because we got a numerator and a denominator. 3 is my numerator. 7 is my denominator. And in parentheses, I've got to have my x plus 1. Close the parentheses. So now it looks a lot better. Now it actually looks like what we have on our paper. Do the same thing, hit graph. So this is what the graph looks like. We'll get a rough sketch of that. Mine's a little off, but it'll work. What we're concerned with is the intersection. Where are those two lines crossing? Well, remember, the way we did that was we went to second trace. We used number 5 intersection. Just remember you have to hit enter 3 times. And you'll notice down there at the bottom, we get 2 numbers, -6 and -2.142857. Now that last number over there, the y value is a decimal, which is okay. It's not going to be that big of a deal for us anyway. Because the one we're concerned with is the x value. So we'll just put -2.1 for the y. All right, so let's do that. -6 and -2.1. That's good enough. Again, the answer is sitting right there in front of us. This right here is our solution. X equals -6. If we look in our table, right next to that -6, guess what you're going to see right next to the -6? -2.1 and -2.1. So if we want to find the solution in our table, we're going to have to look for where the 2 y values are exactly the same number. That's what we're looking for in the table. Where are the 2 y values exactly the same thing?
Do we just put this part from up to -15 divided by 7? So the same thing.
For what?
For the -6.
Those are fractions in that.
What's in the what?
The y1 and y2.
Oh, they gave it to you in the fraction form?
Yes, sir.
Oh, wow. Let's see. So if I go to my table, oh, cool. That's nice. I didn't know that. I didn't know that. Yeah, you can do it. But notice, if we still look next to the -6, they're still the same number, though, right? -15 over 7 and -15 over 7?
Yes, sir.
Oh, yeah. That's going to be good for us. Yeah, you can put it in fraction or decimal. It's all the same. I just learned something. You guys taught me something. All right, so you get the idea, right? That's what we're doing with the calculator. The next part, though, that takes care of the graphing part. But sometimes, like you guys, how many of you actually have one of these calculators sitting at home? Nobody in here has one of these calculators sitting at home. So how are you going to do your homework if you don't have a calculator? Well, you're going to have to do it the old-fashioned way, and that's by doing it algebraic. So sometimes there's just no way around it, guys. Sometimes we don't have one of these fancy calculators, so we actually have to do it by hand. And that's what this next part is. Solve the equations by hand, doing it the algebraic way. So they give you some steps here. Step 1, clear your fractions. Step 2, clear your grouping symbols. Step 3, simplify each side. 4, put the variables on the left. 5, solve. 6, adjust to specific domain. And 7, check for reasonableness. All right? So let's take a look at some that have that we have to work out algebraic. So here we go. Number 4. Number 4. Now again, we're going to assume I'm at home, I'm trying to do my homework, I don't have a calculator, so I got to do it the old-fashioned. So here we go. Here's what we're working. First thing we're going to have to do is use some distributive property. We got to get rid of the grouping symbols. Here we go. We're going to start by multiplying 2 times 17. 2 times 17 is 2 times 17. Anybody know 2 times 34. There it is. You also have to multiply 2 times a negative 5w. 2 times a negative 5w is a negative 10w. Then we go to the other side, do the same thing, distributive property. 2 times 3w is 6w. And 2 times 1 is 2. So I did that first step, get rid of the grouping symbols. And I did that using distributive property. Now you'll notice here I've got a w on the left and I also have a w on the right. I want them all on the same side. Usually we move the w's to the left. So I'm going to do that next. I'm going to take these 6 w's and I'm going to subtract them. I'm moving them to the left. So that 34 is still there. A negative 10w minus 6w is going to be a negative 16w. Of course, this w's are gone. All I have is a 2 on this side. Since I'm trying to get w by itself, the next thing I'm going to do is subtract my 34. That's no longer there. I've got negative 16w is equal to 2 minus 34. 2 minus 34 is a negative 32. I'm almost there. I've got one last step, and that's to divide by negative 16. I want w by itself, so I'm having to divide by negative 16. So what's a negative 32 divided by negative 16? 2. Positive 2. So the solution here is positive 2. So you can see there's a lot more work having to do it this way versus just putting it in your calculator and finding the intersection. So you can see where that calculator does come in handy, right? Would you rather do it this way or put it in your calculator if you had one? For me, I'd probably choose the calculator as well, right? All right, let's do one more here. One more, number 5. We're going to do it the same way. We got 3 over 14 times x minus 4 equals 3 over 7 times x plus 1. We're going to start off pretty much the same way we did number 4. We're going to have to use some distributive property. So let's do 3 over 14 times x, which is 3 over 14x. Then we're going to do 3 over 14 times a negative 4. Now remember, guys, it's just like I showed you earlier. You can actually put that in your calculator as 3 over 14. So get yourself a nice clean screen there. Do that green button, the alpha button, and y equals. Get your fraction. Type in 3 over 14. And multiply it with a negative 4. So now the fraction actually looks like a fraction. You don't have to use parentheses anymore. Anytime we want a fraction, just go to the green button and then the y equals. All right, so the question is, what do you get when you multiply 3 over 14 times a negative 4? Negative 6 over 7 equals, we'll keep going here, 3 over 7 times x is 3 over 7x. And 3 over 7 times 1 is just 3 over 7. All right, so here's what we have so far. Now, I don't know about you guys, but if I can avoid working with fractions, I like to avoid working with fractions. Anybody here like working with fractions? All right, so you're like me. I don't like working with fractions either. So here's what we can do to take care of that problem. I'm going to take this whole equation right here, and I'm going to get rid of all those fractions in one nice, easy step. Here's what I'm going to do. To get rid of all these fractions, I'm going to multiply everything by a... Anybody want to take a guess what I'm going to multiply by? Nope. Nope. 14. 14. Where the heck did I get a 14 from? Well, if you look at the denominators, guys, 14 was one denominator, 7, 7, and 7 were the other denominators. What is 14? 14 is the least common denominator. That's all it is, okay? So, why am I doing that? Well, look what's going to happen here. This 14 and this 14, what's going to happen with those 14s? Cross out, leaving us with 3x. Look what's going to happen over here. That 7 right here, that denominator, 7 goes into 14, doesn't it? How many times is 7 going to go into 14? Twice. So we're going to take that 2, and we're going to multiply it with this 6 right here. 2 times 6 is 12. Keep going. You're going to do the same thing again. This 7 right here goes into that 14 twice. And that 2 times the 3x is going to give us a 6x. We're going to do that one last time. That 7 will go into that 14 twice. And 2 times 3 is 6. So now I'm working with this here. I'm working with 3x minus 12 equals 6x plus 6. That's a lot better than having to work with this ugly fractions up here. All right, so let's keep going. Let's finish it up. Let's get all the x's on the same side. Let me subtract these 6 x's. No more x's on this side, just the 6. 3x minus 6x is negative x. Next thing I'm going to do is add the 12. I've got negative 3x is equal to 6 plus 12 is 18. And I got one last thing to do, and that's divide by negative 3. And what are you going to get when you divide by negative 3? 18 divided by negative 3 is a negative 6. So our final answer here is negative 6. Again, that's a lot of work there. So if you had a choice and doing it this way or using the calculator, which route are you going to go? Probably the calculator route, right? It's a lot easier to find the intersection rather than having to go through all of this. So I'm just giving you options. Some of you like doing it the algebraic way. Hey, stick with it. Go. If you like the graphing way, hey, as long as you got a calculator, you can use that method as well. All right? We're going to go ahead and stop right there. I'm going to give you a couple of try on your own, but as far as the examples that we're going to do together, we're going to go ahead and stop right there, guys. Okay? You got any questions about 4 or 5? Okay? If I give you a test right now, we're all going to pass it? No? All right. Everybody say bye.